Hey guys, so today we're going to talk about the empirical rule. Now, the empirical rule, it talks about if we have a normal distribution, so a symmetrical set of data, 99.7% of the data lies within 3 standard deviations. Okay, now remember, standard deviation, that's the average distance from the mean. So X bar is what we use to denote what a mean. So standard deviation. Now, if you guys remember finding the MAD, that mean absolute deviation, that formula that was horrendous, yeah, standard deviation formula is just as bad. Now, we don't have to actually find that, which is nice, because if you actually did have to find it, there are graphing calculator would help you to find it a lot quicker. There's also Excel spreadsheets that could help you too. So the empirical rule. So our mean is in the middle of our normal distribution, because again, if we have a normal distribution, the best measure of center is the mean. It's the most accurate. So I'm just going to split this up. So that'll be 1 standard deviation, 2 standard deviations, and different 3 standard deviations. So within 3 standard deviations is 99.7% of our data. Now, if you have data that's slightly skewed, so it doesn't technically have an outlier, but something that's close, or maybe it's just barely, that's something that would fall into this tail end, either on the left or on the right, depending on if it's a smaller number or a larger number. But when we're looking at this, there is a rule. So within our first standard deviation, so 1 standard deviation to the left, 1 standard deviation to the right, we have 68% of our data. Okay, so that's our mean, which is denoted by X bar, or it's also denoted by mu. Okay, so the Greek letter mu plus or minus sigma. So that's just saying that either 1 standard deviation above or 1 standard deviation below the mean. So 68% of our data. So that's a nice hunk. Now, if we go out to the next, so 2 standard deviations away, that's going to have 95% of our data. Okay, so again, almost all of it. So if we go out 3 standard deviations, that's where we're getting our 99.7%. So sometimes they'll be asking, let's see, what's the question? Normally distributed data falls within 2 standard deviations of the mean. Within 2 standard deviations, that's going to be 95% of our data. Now, sometimes we might be asked to look at specific sections. So 68, technically that takes up 2 sections. So if I divide that in half, I've got 34% of my data above the mean and 34% 1 standard deviation below the mean. So if I continue that pattern, here I've got 13.5% on both sides. And then we've got a funky little 2.35%. At some point, you are either going to need to remember these smaller numbers, which really you only have to remember half because it's reflected, or these larger numbers, and then just do your division, addition, subtraction to work backwards. But you do need to know these percentages because you will be asked these questions. So we've just got a little 0.15%. So a portion of a percent, just a little bit on the tails again, maybe if you have an outlier or something. But normally distributed data follows this principle. Again, anytime you have an empirical rule, a theorem, a postulate, something like that, That's just telling you that somebody collected a ton of data and found these patterns. That's all that's saying. So when given a mean and a standard deviation, how can we find the spread of the data? Well, by using whatever the standard deviation, you can figure out how far out is it or how far below. And when I say it, I mean the mean. So how far above it, how far below it. What else do I need to tell you? So if your data is really close together, so if you have a small standard deviation, that's telling you that your data is tighter grouped. Whereas if you have a larger standard deviation, your data is more spread out. So let's look at a specific example. So Kellogg's in Kalamazoo, Michigan has a machine that fills the Fruit Loop cereal boxes with cereal. So you just have a machine. This is not people doing it, but it's telling you it dispenses cereal with a normal distribution, but it has a mean of 24. Okay, good. I was thinking that was ounces. So 24 ounces and a standard deviation of 1/10 of an ounce. So on average, we've got 24 ounces. Maybe I'll do 24.0 since we're going to be using decimals. So if I go one standard deviation above, how many ounces would be in that particular box of cereal? Well, I'm just above, so I'm going to add it, 24.1. So continue that, 24.2, 24.3, and the max that would have would be 24.4 ounces. Okay, so you have to memorize those percentages, but to actually set up your normal curve, your bell curve, is just simple addition or subtraction. So let's do the same thing working backwards. So again, since I'm going to the left, I'm going to be subtracting. So if I subtract an ounce, I have 23.9 ounces, 23.8 ounces, 23.7, and bare minimum 23.6 ounces. So there is a chance that you get a box of cereal on this end, so you might be getting ripped off a little bit. All right, so our percentages. The middle 95% of cereal boxes contain between, middle 95%. So again, 68% lies within our first standard deviation, 95 is all of that. So the middle 95% falls between 23.8 and 24.2 ounces of cereal. So approximately 68%, different color, have between, so 68%, that is our first standard deviation. So approximately 68% falls between 23.9 and 24.1 ounces. All right, so what percentage of cereal boxes contain more than 24.2 ounces of cereal? So more than 24.2, so everything on this side. All right, so now we need to think about our percentages in a specific section. So I've got 34, 13.5, and then I've got 2.35 and 0.15. So containing more than 24.2 ounces is going to be 2.35 plus 0.15. So 2.5% of our cereal boxes contain more than 24.2. Literally, empirical rule. Once you have those percentages down, it's just simple arithmetic of adding things. So what's the probability that a randomly selected bottle, I think that should say box, of cereal contains less than 24.1 ounces? All right, so less than 24.1. So all of that. Okay, so I could add up each of these individual pieces. So I could add up 34, 34, 13.5, 2.35, 0.15, but I'm not. Because remember, this is data. So 50% of my data is on that side, 50% of my data is over here. So here's 50, so I can just take that whole 50 and then just add this missing piece of 34%. Again, if you didn't remember and think about it like 50%, you wouldn't have to. But if you do, it just makes your adding a little bit easier. So 50 and 34 tells us that 84% of the cereal boxes contain less than 24.1 ounces. Okay? So again, when you're looking at these questions, you've got to set this up right here. You've got to set that curve up and fill in your values on the number line. I don't know how you can solve, like you can answer these questions without that, because I know that I've had students in the past, they just try and fly through it and you just make simple little arithmetic errors. So definitely give yourself a nice visual for you to go back and look at, because again, it's just simple arithmetic, simple adding or potentially subtracting depending on what they ask you. However, when you look at these, it's just so easy to mess up on a 34% or a 13.5, like dropping something like that. So take the time to set up your normal curve, your bell curve, and fill in that number line to help you figure out what are you adding, subtracting, things like that. And if you've got colors, definitely color code it because it does help. All right, well, I hope you guys have an awesome week. I will need to see your notebook checks this week. So all I need you to do is just send me a picture of your summaries, please. And I have made a Quizlet that you will be doing the learn on the Quizlet. You can do it as many times as you'd like. The Quizlet is also your practice test, okay? Because we will be having our test next week. So make sure you look over that Quizlet. Let me know if you have any questions. I'm here to help. Whenever you do your Quizlet, please, if you're not logged into an account that I can see your score, just send me a screenshot that you've completed the Quizlet. I would appreciate it. All right, guys. Well, have an awesome week. Talk to you soon.